So this is the first of the flipped lessons. If you didn't hear me in class, these are the things you need to know. So there's 20 daily points. That's kind of a small font there, isn't it? Let's make that a little bigger in case you're a little bit on the blind side. There are 20 daily points. Okay? You get 5 points for the notes. You get 5 points for working hard in class. And then there's a 10-point quiz. That's how this works. So you got to take the notes. You know, the only way you're going to be able to get the first two and a good grade on the last one is if you start by taking the notes. So you have to take the notes. We'll try to keep these short. It'll be less time doing this than it would be doing homework. All right, so the first thing we have up here is, what is a parabola? It's vocabulary. What is a parabola? In the real world, think satellite dishes. That's a parabola, okay? Eyeglasses. They're in the conic family. They're not really parabolas, but eyeglasses. They have the parabola shape, the conic shape, contacts. Okay? I mention that because they have what's called a focus, where everything is focused to, and that's an idea of a parabola. What else? Shooting a basketball, throwing a baseball, the curvature of those motions, they lay out a parabola. And of course the parabola, the general shape of the parabola is y equals x squared. That's the one we talk about in Algebra 2. You're supposed to memorize that mama function. Next week we'll probably have a graphing quiz because we haven't had one in a while, and that's kind of going to be my focus. This 6 weeks is on graphing. I might do one more basics quiz, but my focus needs to be on graphing with y'all. Then we have a quadratic function, which we'll define on the next page, and then we have Vertex form of a quadratic function, which we'll also define on the next page. So, what is a quadratic function? A quadratic function is any equation written in one of two forms. First one is called standard. I like to call it STD form, but standard form, which is, let's use function notation, f of x equals ax to the second plus bx plus c, where a, b, and c are the coefficients. They are numbers, are real numbers, and a is not 0. Because if a is 0, you don't have a quadratic, you have a line. Or vertex form. Vertex form is something we've already talked about. It's f of x equals a times x minus h to the second because it's a quadratic plus k. Now, what makes us a quadratic is that second power on the x, and that's kind of worth talking about. And it's one of those little things that kids just don't get. That is the big deal about being a quadratic. To be a quadratic, the leading term in standard form must be an x to the second. And when you talk about standard form, not everybody gets standard form. We decrease the exponents. We go from x squared to x, which would be x to the first, to a constant, which is technically x to the nothing. All right, so what is vertex form of a quadratic and why is it useful? Of course, I'll write it again. The more times you write it, the more likely you are to remember what it is, and that's the big deal here, is memorization. Can't fix that. That's a you thing you got to work on. Why is it a big deal? Well, your center or your vertex is at h comma k. Your line of symmetry, which I'll talk about, if I can spell symmetry, is at x equals h. And what else? A is the vertical stretch or compression. And here's the other big thing. It is the easiest form to graph. That's its big deal. It is literally the easiest form there is to graph. And for some kids, boy, it's tough. Part of me wishes that I could think like some of the kids that struggle. So I could tell you how to overcome it, but I don't think like you. And you don't think like me. So what you need to do is you need to replace that little voice in your head that does math with my voice, because my voice is good at it. I've had lots of kids who tell me year after year that they don't hear themselves speak anymore. They hear me. I've had lots of kids tell me that my class builds confidence, but apparently for some it does not. And I'm going to work on that, promise you. All right, so again, what is A? A is the vertical stretch or compression if the absolute value of A is bigger than 1. We have what's called a vertical stretch. If the absolute value of A is stuck between 0 and 1, I know that math speak, you know, that's rough for some. We have a vertical compression. Now, if you don't know, if you're struggling thinking about a number that's stuck between 0 and 1, an example would be A equal to like 3/5, or A equal to, since we're talking about absolute value, like -2/7. That's between 0 and it's between 1. Okay. H, and we've talked about H before. H is the horizontal shift. It is always opposite of the sign inside. It also represents the x-coordinate of the vertex. Big deal there. And then lastly you have K. K represents the vertical shift, and it is the y-coordinate of the vertex. Again, you got to be taking notes, okay? Remember that learning is not a passive process, it is an active process. So be thinking and trying to memorize the concepts, kids. You're going to have to learn to study. This is legit probably the hardest course most of y'all will ever take. And a lot of you won't appreciate me until you get to the next class. And you'll be like, oh, I get it now. All right, anyways. So what's our goal here? So down beneath this we have functions, and we're simply supposed to talk about the transformations, what has happened. And we're going to talk about these in the order of BHAK. Now in this lesson, we don't have B, okay? So our order is going to be hack. I'm going to talk about it in that order, hack. So let's do a lineup process, and this is part of your note taking, and we called this g of x, but it's in the form of a times x minus h squared. And technically there's a plus a 0, so plus k. And we're going to talk about things in the order hack, okay? So we talk about h first. Remember, h is the horizontal shift, and h is -2, because remember, it's always opposite the sign inside. And I've said that, and I've said that, and I've said that, and you need to start believing it. What this means is we have translated 2 units left. If you don't like the word translate, I accept shift 2 units, but we do need to be using proper math terms here, kids. We are juniors. We need to use proper math terms. So we've translated 2 units left. There is no k, so it's not worth talking about. The next letter to talk about would be a. So I see that a is -1/2. Now, some of you probably remember this as initial slope. It is initial slope, but we're talking about this in terms of transformations, not actually doing the graph. What this means is, since a is negative, and I forgot to talk about that up there, but since a is negative, the graph has been, and it's not an x-axis reflection, it has been vertically reflected. Big deal there. And since the absolute value of -1/2 is equal to 1/2, remember absolute value makes numbers positive, the graph has been vertically compressed by a factor of 1/2. So it's only half the height of the original one. Now, what did I not mention up here? I forgot to talk about a right there. It's something I just caught. Nobody's perfect the first time, or third time, or fourth time. Skip the second one there. If a is negative, a vertical reflection, I can never spell reflection right when I'm typing, has occurred. So There's all the little details, the nitty-gritty about these things. This is probably your third run-through on these forms, so you ought to be good. I'll pause real quick, take a small break, BRB. All right, identify the vertex, the axis of symmetry, the minimum or maximum, the domain, and the range of the function. So there's a lot of assumptions here that you remember things, like what is an axis of symmetry? Axis of symmetry is the line the graph has been mirrored over. Will you say reflected or creates a mirror image of the other side? Okay. A minimum is going to be the low value of the graph. And let me say low y value of the graph. And a maximum is the high y value of the graph. All right, there's your big things there. And domain and range, that's an oldie. And, you know, I was watching a kid do enrollment take a test, and they still didn't quite get domain and range. And I know it's a big deal, and you're going to have to learn how to ask about these questions. You've got to learn how to ask if you don't know, especially if you're a college-bound kid. The goal of this class is college algebra becomes easy. That is the goal, 100% the goal. All right, so anyways, vertex. And again, let's do a lineup process here. We're just going to write a times x minus h plus, oh, I forgot the square. It's not a big deal. We know it's a quadratic, right? Plus k. Vertex on this bad boy is going to be at -4, -5. The axis of symmetry, remember that's x equals h, right? So it's x equals -4. And before I do anything else, I really want to see a graph. Hopefully you get good enough where you don't have to have a graph do a lot of these things, because the common approaches in math are graphical, numerical, and algebraic. Usually we save algebraic for last, but this is an algebra course, so I got to teach you the algebra. All right, the axis of symmetry here. So first let's graph it. Vertex is at -4, -5, so I know a handful of y'all really struggle with the xy axis. That's something you're going to have to work on. It is. Let's go up here. I didn't talk about it here, but a is -2. Okay. What does that mean? That means that I have done a vertical reflection. And it also means that the initial slope is -2. So from this point, I'm going to fall 2 units and run 1 in both directions. I've got to run both left and right. That's the thing, okay? That's the thing. Now, the axis of symmetry is at x equals -4. And when you talk about x equals a constant, you know, you're supposed to remember that's a vertical line. And I know that's an issue for some of you because you don't like studying, but that's a vertical line. And I'll change my colors here to make it more apparent. I'm trying to draw as nice as I can, but I'm literally on my 3rd energy drink of the day. I woke up at 3 a.m. today. It's been a long day. So there's my axis of symmetry, and hopefully you can see that it creates the mirror image left and right. Domain. God, I wish I could make this click for y'all, but I've been saying that for 15 years. Domain is your left to right, okay, which means your values of x. Now this particular graph, it is going to run left forever, okay, and it is going to run right forever. And I think most of you will get this, 99% plus, understand that's -infinity to infinity. Or if you're a set builder kid, which you need to comprehend, all values of x such that x is an element of the real. Your range is your y values, okay, your ups to downs. And when we talk about it in a particular order, it's down to up. That's how it's talked about. So it's down to up. And it is your y values. Now, this particular one is falling down. It will eventually have a y value, and we will say approaching -infinity. So the range starts at -infinity, and if we think about, you know, going backwards or whatever, climbing up to here, and the y value here, it looks to be -5. Now, I'm going to put a bracket on that -5 because a bracket means it's a solid dot, it's a real value, it's not an idea like infinity, and that's what it looks like. Or, and hear me out, if you're a set builder fan, all values of y such that y is less than or equal to -5. Easy peasy lemon squeezy, right? For most. For some, it's a pain. And don't take it out on me. I'm just the teacher. All right, what is the equation of a quadratic function with a vertex of -2, 3 and a y-intercept of -1? So let's think about this, and I've got the instructions here. Substitute the coordinates of the vertex for h and k in the vertex form of the quadratic function. Let's just use y because kids struggle with f of x. So y is a times x minus h quantity squared plus k. And this is h, this is k. We'll talk about what this guy is in just a minute. So y equals a times x minus a -2 quantity squared plus 3. Now, we know that taking away a negative is positive, right? So this becomes y equals a times x plus 2 quantity squared plus 3. Now, it told me I have a y-intercept of -1. That means there's an ordered pair there where x is 0 and y is -1. This gives me an x and it gives me a y. What we're going to do is we're going to use substitution to find a. That's what we're going to do. If I have x and y, I can plug them in. So y is -1. It would equal a times 0 plus 2 quantity squared plus 3. I let y be -1. I let x be 0. That's what I did. -1 equals a times, think about this. 0 plus 2 squared, bad looking 2, is 2 squared, which is 4. And then plus 3. And then we're going to do two-step algebra, okay? We're going to subtract 3 from both sides. -4 equals 4a. And we're going to divide by 4, and we're going to get -1. So here's my equation now. I'm going to do substitution again, and I'm going to put that bad boy right there. Y equals, I'm going to write the -1 initially, x plus 2 quantity squared plus 3. Now, in reality, and sorry, this was step 2. In reality, I don't need the 1 because 1s in math are understood, right? And there's my equation. So I've done all the steps there. Now I'm going to do a fourth part in here because it needs to be talked about. And it's a big one. Now, write the equation in standard form, which is y equals ax to the second plus bx plus c. So there's that. I don't know if I'm going to get to use my Jesus meme with y'all. I really don't. It's a shame because I don't know what to do anymore. But anyways, what we're going to do is if something is squared, we're going to write it twice. We're going to do some math, okay? We got to figure out what x plus 2 times x plus 2 is. So we're going to hit this with the FOIL technique. And 3 out of 4 of you know how to do that, but I'm going to focus on this. X times x is x squared. Now I've got that negative. I'm going to keep it for later. X times x is x squared. 2 times x is 2x. 2 times 2x is 2x. You put those two x's together, you get 4x. And then 2 times 2 is 4. So I FOILed, then I'm going to add 3. Next move would be to distribute the negative. You've got to pay attention to detail. Negative x squared minus 4x minus 4 and then plus 3. Next move, combine like terms. Negative x squared minus 4x and -4 plus 3 is -1. If you're struggling with arithmetic, that is a skill you need to fix. It is. You are juniors. Arithmetic is not supposed to be your issue. Before you go to a calculator, why don't you think about what it should be first? All right, we have a try it here. I'm not going to do that one. All right, Write an equation of a parabola given the graph. The height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is at 120 and the path of the ball includes 0, 4. What is the expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax to the second. So here's what we're going to have to do. We're going to have to pull two good points from the graph. We're going to pull the coordinates of the vertex and another good point from the graph. Now this might be kind of small on your end, but on my end it looks like the vertex is at 120. This is my vertex. She's at 120. Another good point is probably the y-intercept right there. That's going to be the order pair 0, 4. If you have the y-intercept, it's always good to go for because x is literally 0. It makes the math easier. All right, step 2 is to plug h and k, or plug the vertex, into vertex form. That's the first step. Plug the vertex into vertex form. And it wouldn't kill you to write vertex form down again. A times x minus h, quantity squared plus k. That's vertex form, boys and girls. Is there not a graphing problem in this? Yeah, there is. Good. All right, so let's do that. It looks to me like y is, remember this is h, this is k. We don't know a. We're going to say take away 1, quantity squared, and then plus 20. All right, now plug other point in to solve for a. I should use the word substitution, shouldn't I? The other point is 0, 4. It means y is 4 when x is 0. And I guess I need to show you all the work because some of y'all think what I do is magic, and it's not. But 0 minus 1 squared is a negative 1 that's squared. And if we square a negative, guess what it's going to be? It's going to be positive. It is. Now, what a lot of y'all will do is you'll kind of default to using a calculator. That's what you'll do, and you'll do something silly like this. You'll take negative 1 and square it. You'll be like, but my TI-84 said it was negative 1. That's because you forgot your parentheses. Take a negative 1 and square it. And by God, your calculator is going to tell you the right thing. It's positive 1. So attached to this a is a 1. So 4 equals 1a, and I'll drop that in a second, plus 20. We're going to do two-step algebra. There's a reason they make two-step equations such a big deal in Algebra 1. We just shift that 20 over. 4 minus 20 is negative 16, and we're more or less done. And we're going to substitute that back into place. That needs to go right there. And here's our equation. Y equals negative 16 times x minus 1 squared plus 20. The 16 is actually a big deal. This was free-falling motion, and we're going to talk about those type of equations. Hopefully those don't bother you too much. All right, the function g is a translation of the parent function f. 1 unit left and 3 units up. 1 unit left says that h is negative 1 because it's the horizontal shift. 3 units up says k is 3. What is the equation of g? Write it in vertex form and in the form f of x equals ax squared plus bx plus c. So let's start off with vertex form. Again, sorry for the handwriting. I've literally had 3 energy drinks today. Hopefully that's not a problem. I guess we'll find out. And we're going to feed these things. We're going to put that guy right there. We're going to put that guy right there. Now, I'll talk about what a is in a minute. If we do x minus a negative 1, we end up with plus 1. Remember I've told you when you enter parentheses, you change your signs. And then plus 3. Now, what is a? What is a? I don't know. Actually, I do know. So the mother function is y equals x to the second. Technically, there's a 1 in front of it. Now, since they did not talk about a vertical stretch or reflection, A is still an understood 1. So my final form of this equation, and I'm not going to judge you if you put the 1 there. I'm not. I do wish you would kind of understand that you don't need it. But there's my final form. I say I won't judge you. A little bit I will. I'll be looking forward to the day when you stop writing it. I will be. Now, this would be, of course, vertex form. So now we need to do standard form, right? To do standard form, all we do is we write the things, and I guess I should probably be giving you more instructions. So we're going to write the squared piece twice, and then we're going to FOIL that out, and then we're going to combine like terms. And it's worth talking here. I'm going to spend a little more time on this because I do have a significant number of you that cannot FOIL. But x plus 1 is squared, so it needs to be written twice. Now, traditionally in a math class, we teach the FOIL method, which means first, outside, inside, last. Okay? So this would be the first 2 terms. X times x is x squared. Outside would be x times 1, so plus an x. Inside would be 1 times x, so plus another x. Last is 1 times 1, which is 1, and then plus 3. And we get y equals x squared plus x, which is twice x, and 1 plus 3, which is 4. Now, let me show you another technique. If I taught in Southeast Asia, we would draw a box. This is how they usually teach it over there to their 7th graders or 6th graders, quite young. Asians are not necessarily smarter than Americans. If you don't make certain grades, you go to the workforce. We're going to make the height x plus 1, and we're going to make the width x plus 1. Now, inside each box, we do x times x, which is x squared. Here we do 1 times x, which is x. This box is 1 times 1, which is 1. Oh, I did that wrong. This box is 1 times 1, which is 1, and this box is x times 1, which is x. And you can see we have x squared plus 2x plus 1. Another thing which I think is kind of odd is that, you know, in middle school they do multiplication vertically, right? And in high school we do horizontally. I've had a couple of kids over the years that I know cannot do horizontal multiplication. So let's go old school. 1 times 1 is 1. 1 times x is x. X plus 1. Now, on the second line, I don't know if you remember, you're supposed to shift. You're supposed to put a 0 first. X times 1 is x. X times x is x squared. And then we just add down. Vertical multiplication, I don't know why we as a society got away from it, but it still works. It still works. So we can also say that's x squared plus 2x plus 1. So again, I spent a little more time on that than probably you'd like. Most of you probably zoned out about 10 minutes ago, to be quite honest with you, because it was a math lesson. If you have trouble sleeping, just wait. When you wake up at 2 a.m., just put me on. Let my voice put you back to bed. Anyways, see you tomorrow. Hope you enjoyed the lesson.